Hello, Accelerated Math 7-8 students. We are completing Module 10, Lesson 15 today. And the name of that lesson is Solving Area Problems Using Scale Drawings. And we can find that on page 67 of my comp book. So we're going to turn there now. And here is page 67 of my comp book, Solving Area Problems Using Scale Drawings. Our goal for today is, today we will use areas to determine scale factor of drawings. Question, how do you determine the scale factor from drawings? That's what we're focusing on today. So I really need you guys to pay attention in this lesson because this can be a very easy concept or it can be an extremely difficult concept if you're not giving me your full focus. Things to know. Organizing information is very helpful when finding scale factors. So one way that you can do this is by using this organizer to help you figure it out. So basically, I just drew a box, and your job before you're doing anything else is to draw the box and plug in what you know. So as you can see, the top tells us what is the information we're looking at. We are looking at drawing 1, drawing 2, and a formula. We are going to show the side lengths for drawing 1 and drawing 2, and then plug them into our formula, quantity equals percent times whole. Then after we have that figured out, we're going to take the area of drawing 1 and the area of drawing 2 and plug it in to the use of the formula and see if they match. So if we take a look at this, this gives us some practice to figuring it out. So it says, when asked to find the scale factor of drawings using area, you find the scale factor of the side lengths, then you square it, and then you multiply it by 100 to turn it into a percent. So there is a very specific way of doing this. Find the scale factor of the side lengths, square that scale factor, and then multiply it by 100 to turn it into a percent. And then I threw in a little practice problem to have you try just to see if it makes sense to you. So we have this rectangle here. The length on this rectangle is 15 units. The width of this rectangle is 12 units. The length of this rectangle is 6 units. The length of this rectangle is 4 8/10 units. So we need to take this information that we have, plug it into the box to organize it, and then determine the scale factor, and then also determine the area of the scale drawing. So that's what we're going to do. So we're going to use the box. I'm going to draw my box down here. You're going to use the box in your comp book, and we're going to get our information done. So we have scale drawing 1, we have scale drawing 2, and we have formula. Spell it right. Then we have side and area. Okay, so on scale drawing 1, that's going to be this one, we know that there's a side length of 15. For scale drawing 1, we also know that there is a side length of 12. You have to keep corresponding lengths together. So 15 corresponds to 6, and 12 corresponds to 4.8. So our job is using the formula. If you're going from scale drawing 1 to scale drawing 2, scale drawing 1 would be the whole. So you have 15 times the scale factor gave me 6. So that's what we're trying to figure out right there. 15 times what scale factor gave me 6. Okay, so we're going to go ahead and try it. We can also know that you would say 12 times what scale factor gave me 4 8/10. All right, so the way we figure this out is a regular algebraic problem. We have 6 equals r times 15. So you're going to use your BU chart. And let me get it up so you can see that. All right, so our variable was r. What we did to r is we multiplied it by 15. So now we have to divide it by 15, and that should give us r. So I'm going to divide this side by 15. What you do to one side, you have to do to the other. 15 divided by 15 is 1. 1 times r is r. 16 divided by 15, I'm going to simplify it just to make the math easier. I know 6 divides by 3, 15 divides by 3, so I'm left with 2/5. That's very easy to complete into hundredths to get my percent. 5 times 20 makes 100, so 2 times 20 is 40. So now I know my scale factor is 40%. Okay, let's test it with this other equation to make sure. So we have 4.8 equals R times 12. I'm going to divide this side by 12, divide this side by 12, and I know that I can simplify this, or I can just divide, which is okay. I actually am just going to divide. 12 goes into 4 0 times. 12 goes into 48 4 times. I brought up my decimal point, so I get that, and then I have to take this number and multiply it by 100. So I have 0, 0, 4, and then I have to move it over one decimal point. So I now see that the scale factor for this one equals 40 as well. So now, if we go back to what it says, find the scale factor of the side length. So our scale factor was 40%. I'm supposed to square that. So before I change this into a percent, so I skip my step, which you don't want to do. Let's take this one right here, okay? If you take 2 divided by 5, what do you get? 0.4, yes? So we're going to take 0.4 and we're going to square that, because that's what it told us to do, is find the scale factor of the side lengths, square it, and then multiply it by 100 to get to a percent. So we need to square this. So squaring means you take the number inside the parentheses and you multiply it by itself the number of times that it says. So I have to take 0 and 4 tenths times 0 and 4 tenths. 4 times 4 is 16. Regroup the 1, so I get it down here. 0, 0, add those together, and I get that 2 places. So that is the area scale factor right there. That is the area scale factor because I squared it, and area is always squared. So now I take that number and I multiply it by 100, and I get 16% is the scale factor for the area. Okay, so the scale factor for just the side lengths is 40%. The scale factor for the areas is 16%. Okay, now let's see if it works. What is 15 times 12? Because you all know that to find the area of this rectangle, you multiply your side lengths together. So that's 10, and that's 3, that's 5, and that's 1. Add them together, and you get 180. And then we're going to take 6 times 4.8, so we get 48, regroup, 24, 25, 26, 27, 28 here, one place, so that's 28. Did I do that right? Sorry, it's very hard for me to go upside down. Yep, okay. So this amount right here should be 16% of this if we did it right. Because remember, we're going from the big one to the little one. So let's see. 28.8 equals 16% of 180. So let's see if we're right. Remember that to do this, you have to divide by 100. So either way, you can take 180 times 1.6, and let's see what we get. That's 20, 0, 8, 1, 0, 8, 8, 3. Let's see. I'm wondering if I did some math wrong here. Hold on. So 0, 48, 6. Aha! That's supposed to be a 10, not a 20. Sorry, I did do math wrong. So 0, 8, 1. Okay, add them together. 0, 8, 8, 2. 2 decimal points. Ta-da! Did it match? It totally matched. Okay, so we did it right. All right, so the other way you can do it is take the area of this one, take the area of this one, and then you see that they match. Okay? All right, so it may seem overwhelming and kind of confusing at first, but if you match these steps with what it says to do, this whole process can be really easy. So let's go back to our goal. Today we will use areas to determine the scale factors of drawings, which we did. Question, how do you determine the scale factor from drawings? Okay, that's a pretty in-depth question because we've got a lot of different information that could be answered. Use the box. It's really, really helpful to set up your information. So remember, we did this one. I'm sorry, we didn't fill this in. So the area of scale drawing 1 was 180. The area of scale drawing 2 was 28.8. And then we figured out that the formula would be 28.8 equals R times 180. And you should figure out that it's 16%. Okay? So don't panic. Set up the box. It's a really good tool. I will be here to help you practice, and we'll get it done. All right, my darlings, that's it for today's lesson. We will have some more practice problems in class tomorrow, and I'll see you then. Bye.